All right, folks. Hey, sorry I'm not there today. Out of state for Monday and Tuesday attending a family funeral. So I figured if I made you a really short bare bones video for today and then another one for tomorrow, that at least give you guys off to a good start. It's a little less flashy than what I'd plan on doing if I were there, but we're going to keep it simple. You have the worksheet in front of you, and I'm hoping, hey, stop working on the worksheet, watch this video. It's short, it'll help you out a little bit. What we want you guys to think about are the kind of problems we were doing last week. Hopefully you've already collected or turned in, I should say, the FIDO problem. If you haven't, go ahead and give that to the sub. And as you're looking at this example here, it says that, you have this builder and she's designing a rectangular parking lot and she has 300 feet of fencing to enclose it with, all right? Now, what's important to understand, though, is that the parking lot only has 3 sides. Obviously, there's going to be the entrance, and we're not going to have that side enclosed. So you have this right here is not going to be counted. This is similar to when we built the dog pen up against the house. So keep that in mind. As you look here, we have 300 feet of fencing. That means if this is W and this is W, then this side here would be 300, take away the 2W. 300, take away the 2W. Now what we're going to be discussing today, and this is similar to what we did last week, is finding the formula, or the expression I should say, for area. And you should all know that area is equal to length, which was 300 minus 2W, times width, which was just W. So when we go to find that area, you'll see written there, what they did was, they just multiplied, they wrote an A sub of W, and they multiplied the W times the 300 minus 2W, and they literally multiplied it out. And they're going to get what's called a quadratic. We're going to get those. You're going to have an exponent in there. When you distribute this, you're going to get that 300W that you see right there. You're going to get the W times negative 2W. It gives you negative 2W squared. That's where that's coming from. If we graph that on our graphing calculator, so we have W times 300W squared. (300 minus 2W). What you'll notice is you get a parabola, all right? We're going to get this parabola. We should not be surprised by this. That's what quadratics look like. And it's open down. Why is it open down? Because we're graphing that width compared to the area. And what happens is, as we make that pen wider, the area gets bigger. But then there's a certain point to where as we make that pen too wide, it gets too thin, too small of an area. So that there is a peak. There's a maximum. Oh, I got to put my pen away. All right, right there, get rid of that. And the maximum is at 75. When we make it a width of 75, boom, we have an area that's maximized at like 11,250. So at 75, let's look at that. So when this is 75 right here, let me erase all the stuff I put on there. When I make a width of 75, and this is 75, then that means that 2 of those, 75 and 75, make 150. So that make this 300 minus 150, which is 150. So when I make my pen 150 by 75, that's when it would have its maximum area. Now, the first problem that you're going to do, I'd like for you to try it in your groups, and then you can start this video back up. Pause it for now, start it up, and this is the only one I'm going to do with you. So please give it a shot, and then start the video back up. All right, so they said ACO is enclosing a new rectangular flower garden. Now notice, she's putting it on all 4 sides. She's putting fencing on all 4 sides here. So she's going to have a W here for width, a W here. Now think about that. If I have 40 feet of fencing, what do I know that my 1W and my length and width have to add up to half that fencing, right? Because we learned last week that a single length and a single width make up half the rectangle. So half of 40 is 20. So if I know that W and this length have to add up to 20, that means this is going to be 20 minus W. Then the bottom and the top will both be 20 minus W. So what's W? W is width of the garden. Width of garden. What am I going to say for length? Don't you dare put L in there. It's 20 minus W. Remember we learned last week, you don't put 40 minus W in there. It's 20 minus W because you're only dealing with half the rectangle when you talk about that 20. What's the area going to be? It's going to be the product of the multiply width times length. So W times 20 minus W. We've got to multiply those two things together. So you have a W and a 20 minus W, and when we multiply those two together, we get the area of the garden. Now, they say to rewrite that expression in standard form. Okay? Rewrite that expression in standard form. And we got to complete this table over here. So here we go. What's the area going to be? Area is going to be, if we were to write an expression for it, it'd be W times 20 minus W. Now we distribute that. You take W times the 20 and W times the negative W. And you get 20W minus W squared. And we would be able to stop right there, except for the fact they want it in standard form. That means that the W squared has to come first. So when we write this, we should write the minus W squared first, and then plus 20W. That's the expression in standard form. Now use that to fill in some of these options. And I don't care what you filled in. Everybody in the room could have picked different values. But what you do know is you can't make the width bigger than 20. So you better pick widths that are like, I don't know, 4, 6, 8, and 10. I don't care. You can make up any numbers you want. And then you fill it in. You say, hey, I know the length and the width have to add up to 20. So if I pick a width of 4, length better should have been 16. With a width of 6, I should have had a length of 14. With a width of 8, I should have had a length of 12. And with a width of 10, I should have had a length of 10. Now, what did we learn last week? If you want to maximize the area for a rectangle, you make it into a square. So we get an area here of 100. 12 and 8 make 96. 6 times 14 was at 84. And 4 times 16, area of 64. Your table might be totally different than mine, but I can tell you right now that 10 length and 10 width is going to give you the maximum area. That 100, when you go to graph this, W times 20 minus W, and I'll prove it, and then we'll be done with our notes. That minus W squared plus 20W I gotta zoom in here because I was way out there. There we go. All right. That's the graph. This is what we've been talking about. And if you look at the peak, it happens right there at 10, 100. So that means when the width is 10, the maximum area is going to be 100. Give those problems a shot. This is your homework. This worksheet is your homework for tomorrow. Give it a try.